Hello, honors pre-calculus students. Today's learning target is to write sine and cosine functions for various applications. So the first thing we need to do is remember the generic form of a cosine and sine graph. So it's y equal a sine b x minus c plus d. This should look familiar from transformations. Or y equal a cosine b times x minus c plus d. So you may remember A is called the amplitude. It's the vertical stretch. B impacts the period. It is the horizontal stretch or compress. C is the horizontal shift. And D is the vertical shift from our previous unit. So if you pause the screen and read this problem, you'll notice that it says it takes 7 minutes to make a complete revolution. Actually says that twice. That indicates that the period is 7 minutes. So we know that the period is equal to 7 minutes. So a full ride takes 7 minutes. You may recall from last year that the period is equal to 2 pi over b. So I'm going to solve for b. 7 is equal to 2 pi over b. Some of you will cross multiply and say 7b is equal to 2 pi, which makes the b value 2 pi over 7. So the period is always 2 pi over b. Continuing to go back to the problem, it says that the ride is 150 feet high, so I know that that is the maximum. Continuing the read, eventually you'll see that the diameter is 140 feet. That's going to help me find the minimum. Since you're at 150 feet and the diameter is 140 feet, if you subtract 150 minus 140, you will get the lowest point to be 10. And looking at part B of the problem, we need to make an assumption where we start. So it says let x represent the time and assume at x equals 0 you're at the bottom of the ride. So we're going to start at the bottom of the ride at 0, 10. We know it takes 7 minutes for a complete revolution, so another point is 7, 10. Since this is modeled by a sine or a cosine graph, the midpoint of 0 and 7 is 3.5. So at 3.5 minutes, I will be at my maximum of 150. At this point, you might recognize the graph, so I'm going to sketch it in here. And now we need to remember some of the other ideas that we had learned in Algebra 2. One of those ideas is the sinusoidal axes. The sinusoidal axis is this dotted line I am drawing in red. And in order to find the sinusoidal axes, you can take the average of the minimum and the maximum. So you add up 150 plus 10, divide by 2, and you'll get 80. So y equal 80 is the sinusoidal axis. The other piece of information is we need the vertical stretch or the amplitude. The amplitude is the distance between the max and the sinusoidal axes. So 150 minus 80 will get us the amplitude is 70. So at this point we have the information to write a sine and a cosine graph. So in the bottom right hand corner I redrew the cosine graph, and point A is typically my focus. Now if you look at the graph, I'm going to put A prime here. Notice it starts at the bottom, so that's a reflection of the graph. So y is equal to negative 70 since there's a reflection. Cosine, we calculated the b value to be 2 pi over 7. Since this is simply a reflection, there is no horizontal shift, so it's x. And then the sinusoidal axes on the regular cosine graph is at y equals 0. I'm drawing that in red. Well, that graph was moved up, so the vertical shift was 80. There are other cosine graphs you could write. Our focus is always point A on the bottom right corner. So if I wanted to focus on this point A prime, this time there is no reflection because we're starting at the top, so y is equal to 70 cosine. The b value is still 2 pi over 7. But this time we're shifting over 3.5. So from our transformations unit, it'd be x minus 3.5 and then plus 80. There are infinitely many sine and cosine graphs. I could have used the point at 710, but one of these two hopefully resonate with you. Now let's try to write a sine graph. For the sine graph, I redrew the sine graph over in the right-hand corner. The sinusoidal axis is this blue dotted line. So my focus is this point that I just highlighted in blue, A. It's on the sinusoidal axis. So on the Ferris wheel problem, I need this point that I just highlighted in green, which is right between 0 and 3.5. So 0 plus 3.5 divided by 2 is 1.75. If you wanted the second green dot, which is in between 3.5 and 7, you would add up 3.5 plus 7, so 10.5 divided by 2, you get 5.25. So if you're trying to write a sine graph, you want to focus in on one of the green dots. So I'll call this A prime. So my goal is to take the blue point A, and I needed to move it. So y is equal to, notice the graph is increasing, so 70 is the amplitude, there's no reflection. Sine, the b value is still 2 pi over 7, and the shift is over 1.75, so it's x minus 1.75, and then the vertical translation is up 80. If I wanted to, I didn't have to use that point. I could have focused in on this point, the second green dot, A prime, but this time, notice there is a reflection, so y is equal to negative 70 sine 2 pi over 7. This time the shift is x minus 5.25, and then it's still plus 80.